All right, well, welcome back everyone to our last panel discussion of the symposium. We've truly enjoyed the last 2 days and deeply appreciate all the contributions made by the presenters and all of the inquisitive energy provided by the audience. As we begin our conversation in this space yesterday, the commencing conversations were led by our regional foresters focusing on ecology, followed by amazing posits and call to orders on energy, emerging carbon. After hearing from our mass timber manufacturers, today's presenters shared practical applications through a discussion on code, material science, and material tectonics. The last conversation was a truly amazing investigation into academy and making, and now I'm honored to introduce the design practitioners whom we've gathered here today to share their very personal and practical wood attitudes. So starting first with Kevin. Kevin Daly is the founder of Kevin Daly Architects, and internationally based out of Los Angeles and New York City. KDA is a recognized architectural practice focused on craft, construction, material systems, and high performance building. Their commitment in the search for new approaches to sustainability is grounded in the need to find livability and economic viability to an uncertain future. Their work includes environmentally and socially responsive educational, residential, and institutional projects ranging in scale from single room workspaces to campus planning. Thanks for being here today, Kevin. Jonathan Tate is the founder of the New Orleans-based practice, OJT, an office working on a range of projects, including architectural planning, transit, education, hospitality, and cultural programs. OJT recognizes the complications in the design and building process and aims to leverage them to find the exciting and potentials within the in-between space. Recently, OJT was included in the list of firms that make up the Northwest Arkansas Design Excellence Program. Roberto De Leon, FAIA, is a co-founder of De Leon and Primer Architecture Workshop, a collaborative design studio focusing on public projects with a cultural, civic, or not-for-profit basis. DPAW's working methodology draws inspiration from regional traditions of craft and fabrication, placing an emphasis on the potential of conventional materials and construction methods. The studio purposefully embraces a design rigor aimed at simplicity and precision with the underlying premise that innovation necessarily equals economy. DPAW was chosen for the 2010 Design Vanguard by Architectural Record and the 2011 Emerging Voices by the Architectural League of New York. Right now we have Ruth Mandel and Bobby Johnson will be joining shortly. Co-adaptive is a process-oriented architectural practice founded in 2011 in New York City by Ruth Mandel and Bobby Johnston. The practice focuses on retrofitting existing buildings to create energy efficient, climate resilient, and spatially beautiful environments. They are passionate about using the passive house design methodology to create quiet, comfortable, and high performance buildings. Their design process is also attentive to the functionality, durability, and embodied energy of materials, and they work to create buildings with a minimal carbon footprint that endure for decades to come. Co-adaptive believes in their responsibility as architects to understand the design of one building as part of a holistic system whose component parts have an effect on our collective environment. Thanks for being here, Ruth. Last but not least, we have Z. Smith and Mike Johnson from SQ Dumez Ripple. Z. Smith is a principal and director of sustainability and building performance at SQ Dumez Ripple. Mike Johnson joined EDR in 2016 and is an associate. EDR's work enhances lives. Established in 1989, SQ Dumez Ripple has transformed from a local firm doing nationally recognized work to a national firm that has retained its local roots. They were the recipients of the prestigious 2014 Architecture Firm Award and have continued to find meaningful ways to shape community and the profession at large. EDA crafted beautiful buildings that celebrate their native places, providing a framework for the life that occurs within and around them. EDR Studio was founded on the belief that such diversity lends richness to the design process and the buildings that emerge from it. So thank you, everybody, for being here. And with that, I'll hand it over to Kevin.
Thanks so much, Shauna. Let's see, let me share my screen and switch this to full screen mode. Thanks for the invitation. It's a super provocative, you know, set of topics. I would say that, you know, it's sort of forced me to think a little more, you know, kind of thoroughly about the sort of means and kind of technology that we use in our own work. I think, you know, we kind of collectively as kind of practitioners, I think
Kevin, sorry,
yeah.
we're not seeing your full screen mode. But
Okay, let me try. You're seeing two side-by-side images, but not full screen.
Correct.
There we go.
Sorry to interrupt.
That's all right. Bluebeam always does its best to kind of get in the way of what you're trying to do. I think that as practitioners and as designers, we've tolerated a kind of dissonance with respect to, you know, wood and wood construction. And wood systems are, I think, in that regard, seen as being both extremely normative, you know, the Home Depot, the kind of Simpson hardware, and, you know, and absolutely transcendent, you know, Wegener, and, you know, the kind of the, you know, the beautiful, you know, kind of, you know, the wood that is, you know, transcendent for its materiality and its kind of properties. And that ambivalence, you know, it really, I think, affects every level of our own practice. In architecture history classes, we learn, you know, about, you know, J.B. Jackson and the kind of the impact of, you know, the landscape changing impact of balloon framing. And at the same time, next lecture might be on Alto's Villa Maria. So for every kind of industrialized, you know, sense of what wood is about, there's also the Shinto shrine at Ise. And I think that sort of ambivalence is something that affects every aspect of what we do as designers, that wood is both utilitarian and instrumental. So in other words, you know, I need an envelope, I make a balloon frame, with the sort of experiential phenomenon of wood as a tactile and a material presence that shows joinery and finish. And I think, you know, I think that's why this, you know, this kind of conversation today is really relevant. You know, wood is at a moment of reconsideration. It kind of fundamentally can change, you know, the kind of nature of the kind of carbon debt that we're encountering as we build. And I think, you know, there was a reference to Banham's rational use of wood, and I think the implications of that are both as kind of building material that is both kind of renewable, but at this point, obviously not unlimited. You know, so what I would like to do is show a couple examples, kind of current projects. One is, you know, is a building that we used very large roof surfaces and had to be executed out of timber. And the second is, I mean, after probably 15 years of trying, the first full kind of mass timber, you know, building that we've been able to execute. And ironically, that came as sort of a value engineering, you know, sort of strategy after other building systems proved to be too expensive. So I think, you know, you know, in that regard, the kind of mass timber application is really something that you know, represents kind of a form of kind of market maturity that we had not expected, or that was not really anticipated not very long ago. So let's see if I can get this thing to forward. So this full screen is really being problematic right now.
If you try Control Enter, that sometimes takes it to full screen and gets you out of all the menu bars.
Yeah. So this first project is a project for UCLA. John Wooden, the kind of, the philosophical leader of kind of athletics, not just at UCLA, but kind of across the country, shown here with Kareem Abdul-Jabbar. We were commissioned to do a building for the basketball practice facility at UCLA. Let me see if Control Enter will work better. And really wanted to kind of rejoin this kind of idea of the very kind of early parts of the sport. This kind of wood as an apparatus, and wood building as kind of as a Midwestern field house. As we started working on the project, really kind of concluded that what we should be doing is building a kind of a series of shells, and you can kind of see in this image that we're using the underside of these wooden shells to distribute natural light onto the floor of this basketball facility. And the distribution of light became critical because the athletic department wanted no visibility into the structure. We oriented the building to be completely north facing. And the kind of accumulation of light and the kind of strategy for bringing in light became the sort of central, one of the central characteristics of how the building was developed. You can see each of these things kind of counterintuitively, they span the long direction of the courts. This kind of constantly changing vault shape was used in order to pull light from the north-facing ETFE clear stories and bounce it and distribute it really carefully onto the floor. The building's intended, since from an environmental standpoint, it was being used by 24 people at a time. We really wanted to kind of absolutely limit the operational requirements for energy to use the building. So you can see these vaults change continuously. It was really important for us to make those out of kind of shaped timber elements. And you can see that in order to contact the top surfaces of each of these joists, there was also that it kind of implied a constantly varying curve. And as we started to develop the project, you can kind of see this under construction here, long steel trusses, wood glue lamp joists that connected them. And I think the thing that for us was interesting, and it was kind of a reminder that in the United States, I think our kind of default technology is carpentry, as opposed to building systems that are kind of fundamentally masonry systems or fundamentally other kinds of systems. I think our default goes back to that Home Depot. And the kind of the skills and kind of capacity that carpentry brings to our work, and the kind of problem solving that goes into any kind of architectural work, I think is really significant. So on one side of this, one side of the image is kind of engineering details. Thornton Tomasetti did a fantastic job on this project. On the other side is the kind of whiteboard that as we went to the job meetings, the subcontractors were really starting to figure out what is going to be involved in making this vault hit the top surface of all these joists, throughout the kind of changing course of the vault in its implementation. So let's see here. So here is the kind of carpenter side of the yard, and I really liked these two images because there was this kind of gap that we tolerated in the start of this project, and that gap really was about the sort of change between the idealization of this and the actual implementation of getting a curved kind of plywood surface onto these joists. And you can kind of see here, these guys are taking a closer look at this tool setup. So there's two things I'd like to point out. So what the carpenters came up with was kind of a variable jig in order to kind of create this constantly changing top surface on these joists. And you can see in the lower right-hand corner, these bolts allow those two steel angles to change in their orientation with respect to that joist, and allow a slightly varying angle to be imposed onto the, to be cut onto the top of that joist. And you can see here this red, so here's the kind of adjustability. You can see those two rails operate independently. And here, I really like this thing because what it looks like they did was bought, an electric chainsaw at like Lowe's, fitted it with a concrete trowel on the top and bolted it to the bar of the chainsaw, and then let that chainsaw run along those angles. And you can see this cut starting to happen here, and then that was just kind of cleaned with a hand, an electric plane. And basically, what we had done was we had extracted an Excel sheet from from our documents showing the length and the kind of nature of that taper, and they found a way to kind of provide an analog alternative to that. And each of those, even though each of those joists changes really substantially, they developed a jig and a mechanism for allowing that to kind of be fabricated in kind of with a single sort of technique. And I think that's the sort of presence of carpentry within our own kind of construction systems that ended up being, a real factor in how we executed this building. So I think it's kind of like, it kind of goes back to this sort of notion of technique as the kind of fundamental sort of, source of momentum in construction. So let me see here. So let me go to this second document here. And this is a project that we are just in the process of designing. It's a foundation in Houston, and this project it's a competition we're working on with this firm Projective in Mexico City. Started as a concrete building in Houston, and let me see here. Give me 1 second. Well, my blue beam gets another grip here.
Kevin, this is Shauna. Maybe we'll move on to Jonathan, and then if we have
Yeah.
time at the end, we can come back to
Yeah,
this.
let's do that.
Makes sense.
Yeah, perfect.
Okay, hello everybody. All right, can y'all see me? No problems.
You look good, great.
Okay, great. Thank you. Well, first, thank you all for having me here, and I appreciate and honored to be a part of this panel today, and I look forward to hearing from the rest of the members of the group. But appreciate the introductory talk too from Kevin, and especially the sentiment about having to reconsider a bit the work that we do in context of wood. And I'll say that we're not of the ilk currently that are using mass timber or some of the other advanced framing types. So but we are someone very excited about the use of wood, and it is certainly a part of everything that we do. So this was an enjoyable process, let's say, but I may stumble a bit through this presentation as a consequence, because this is a new way for me to frame a few of our old things, if you will. So let's see. All right, with that in mind, I thought I would start out by co-opting a line from learning from Las Vegas here. And I thought it was a useful dictum to summarize our practice's relationship with wood. And instead of the billboard in this case, as was suggested in the book, we tend to look at wood as the idiom of our own vernacular. And by wood, I should start by saying that the milieu we work in is squarely in conventional framing, or the modern platform framing system. It can most basically be separated from the lineage of wood construction by its use of standardized, to emphasize that word, framing material. In fairness, a lot of this is out of necessity. It's what our projects call for or what are available to use. Creating the new in this case, however, as we desire to do, does indeed mean choosing the old or the existing. Let's see, nevertheless, we found within this type, there are certain material conventions that we've been able to use to explore important architectural conditions. Our favorite these days is the engineered truss. Nearly ubiquitous in residential and commercial construction these days, it is surprisingly adaptive when pressed. Two projects of ours look at its malleability as a basis for exploring the conventions around exterior-interior logics, and with that, a more general critique of architectural form. So here's your builder's guide if you're ever interested. The first project I'll start with is Bastion Community. It's a multi-unit affordable housing development comprised of 2 family dwellings. There are about 80 units of housing and over 40 individual structures. Let's see, the architectural premise in this case was to advantage a rigorous adherence to a consistent form. In other words, it's the same building multiplied over and over and over again. This was, of course, a way to keep costs down. But in our case, given that there were multiples to work with, we use that, again, to sort of advantage that. And through their manipulation of the site configuration, creating meaningful or desired spatial relationships, defining unit clusters, and specifically scaled social zones. So the real work was how these things were located next to one another, and their manipulation in that sense. But more important to this conversation is how this attitude extended to the sectional conditions of the units themselves. By way of modifying the bottom chord of the truss, we were able to create numerous spatial conditions within the unit. Although any 2 were alike, no 2 were identical in this case. So again, it is sort of poor man's version of working through or manipulating what are traditional systems that we were, impelled to work with here, again, through cost-saving measures, but just that's the nature, or as I say, the idiom of this particular construction type. And with that, in each of these buildings, what we did was we had unique undercord conditions, basically different room volumes throughout the kind of length of the building itself. So we were able to kind of manipulate and add diversity within the structure through the kind of simple manipulation of the truss form, which is, anyone who knows, who's worked with engineered truss, is the engineered truss manufacturer doesn't really care what shape it is. They just want it to work structurally. And so if you understand that as a kind of precondition, then it's just up to your imagination in that case to sort of work through and make use of it. A second project to walk through kind of quickly here was a school that we've been working on in Clarksdale, Mississippi, that involved actually an existing church and the construction of a new building adjacent to it. It's an addition, if you will, but it's unattached. And the massing and the form of the existing building we needed to work with the new building as a way that the 2 sort of intermingled necessarily, at least by client directive, so that we could respect the existing structure. So in this case, it had its own monumental spaces that we wanted to make sure were still present. And then the school itself had its own kind of monumental spaces that need to interweave with that. So in this case, what we ended up with was creating this kind of clear silhouette that intended to obscure the scale of the structure using a playful, intentionally slopey and residential overall form. But behind that silhouette was a complex of rooms, each with specific spatial necessities. So what you see behind the veil in this case was actually a sort of conundrum of different rooms and programs and types and uses. You've got libraries and classrooms, administrative and service rooms. It's a case of do you get what you see for us? And the humble trust was the component that we used to comprise the entirety of this. And so this is it under construction, and I think we all as architects appreciate the sort of repetition and the character and depth that we get whenever we're on these job sites around this condition. And so this one, again, expressive of that particular form. But back to the idea of conventional framing. Let's see, the modernization of framing technique was also importantly a prerequisite for the mass construction of post-war housing. So the idea of platform framing came about at the time that, we've had a post-war boom and consequently suburbanization of housing in America. Let's see, and another construction type used for mass housing predated this and should also be a familiar typology to the audience. And in this case, the sort of construction, the concrete or commercial construction for your typical multifamily housing developments. But recently, what's of great interest to our office is see how the melding of these two has created, in our opinion, the most nefarious typology for housing today. There's a lot to dissect here and no time to do it, but in the context of construction type and the use or advanced use of wood, I think this, what we refer to as the 4/2 typology deserves consideration. And by this, we say pound over pound, but it's number over number, 4/2. And that's, and what that is essentially is the advent of incongruity of the building code, allowing the combination of non-combustible, that is the plinth, with combustible framing, which is the stick-built part, that creates this new housing typology. And there's a fascinating history here which it evolved out of the Northeast and making its way into the international building codes. But along the way, at least in our experience, it's been firmly rooted in the lexicon of most developer and real estate entities in the country. And this is what we're talking about, typical plinth in this case, where you might have parking or commercial on the ground floor, and then your double loaded housing units on the top floor. Let's see, but one reason for it's ruthlessly efficient one reason that is ubiquitous is that it's ruthlessly efficient at neatly addressing the mixed use, mid-scale urbanity found in most American cities. Commercial retail combined with parking topped by layers of repetitive housing, making it the building block of renewal and infill urban development. Another reason is cheap, the wood part anyways. Consequently, is ubiquitous and as a result is reshaping, I'd argue, homogenizing our cities. And these are examples that you'd see in different parts of the country. But to illustrate, we were asked some time ago as part of an ongoing planning project in Newark, New Jersey, to evaluate its deployment in the adjoining city of Harrison, New Jersey. This is, a classic case of post-industrial land reprised as TOD development sites pivoting off of the proximate path station. This is at the time, 2008, these were the current 4/2 developments, and then these were all platted as new 4/2 developments that were coming up in the subsequent years. But as part of this study, we were also asked to consider the potential reuse of a large downtown parking garage and adjacent multi-story building in downtown Newark. Since we were already immersed in the conceptual framing of this building type, the garage presented an excellent opportunity. Here we had our plinth, so we were free to use the top, the wood frame portion, at our whim to express programmatic and formal potentials within this typology. Free to an extent anyways. This is the garage. This was our overly obsessive analysis of it, looking at how parking and the structure of parking actually permits or facilitates the housing development and the actually circulation patterns above it. you can see the obsessiveness here as we were sort of digging into this, but we were free to an extent anyways, as there are rules to housing. The 60-foot bar, building width of a double loaded corridor housing plate is also one of these ubiquitous terms that we're always running into, but that's the rule to follow. And with that, we went about exploring expressions of the construction and formal conventions. So this was the existing deck, and then our approach to how you put the top or the housing block on top of that. And then through that, a series of just analysis about what that form should be. Again, this was our chance to say, or to at least challenge to the best of our ability, what this new typology represented urbanistically, but how the relationships between the two material types specifically could be differentiated or expressed in different ways to address either internal logics with the building itself or externalities in the urban environment in this case. And so this is, again, sort of a series of iterations where we work through what were opportunities on this particular platform. And this is us just having fun with different formal types, again, using the 60-foot bar as a premise. So that dashed line being the corridor for double loaded layout. And then through, again, a series of sort of obsessions over slight modifications and how these modifications created either efficiencies or economies and maximized densities on this particular platform. And then through another, again, series of locations of, circulation cores and types in association with the parking below in order to create, pinwheel configurations and other assemblages on top. And then another series of layouts about how these things work and overlap. And again, sort of despite or in spite of the face of or the exuberance, let's say, of the form, we were looking for what were, again, kind of ruthless efficiencies and economies and the structure type that we were working through. And consequently, this was the sort of net result of us working through that analysis. Can't say that we necessarily solved or came up with anything inventive in this case, but the point is that we were trying to investigate or challenge this as a type and as a new form and as an important sort of building block, if you will, of urban development. But to be clear, wood in this case isn't an exact technological advancement. It's regular old framing. There's nothing new about it in some ways. But its co-option is creating new urban forms, as I said, but whether for good or for ill, if not for wood, I don't know that it would be the same. Let's see. With that, I'll end this presentation by circling back to the passage where I began. I know the importance of advancements in wood are critical discussions these days, certainly for the symposium, but within this discussion, I'll offer that the ubiquitous or primitive vernacular, if you will, is still ripe for invention. Okay, so I will cede my time. Thank you.
I think I'm next, but I wasn't sure if Kevin wanted to continue.
I think to stay on schedule, we'll just move forward with you. But,
Okay, thanks, Shauna. Okay, I'll share my screen. Again, thank you, Shauna and Chris. It's been great to listen to all the speakers the last couple of days. It's been really incredible. Thank you. Again, I'm Roberto Delion with Delion Primer. We are based in Louisville, Kentucky, which occurs at the Falls of the Ohio, which is the only natural obstruction of the Ohio River. A lot of our work is driven by trying to understand the nuances of place and context, which often informs not just the design direction of our projects, but also how we build. We often use contextual precedents and imagery as a starting point with our clients as a way to begin a dialogue with something familiar, but ultimately searching to arrive at something new or reimagined. And I'm going to talk about a sampling or really sort of fragments of our projects in wood, framed within this intersection of contextual narrative, our own internal material investigations, and sort of improvisation with other builders and fabricators. And while each project charts out its own sort of trajectory, they're all sort of unified by these intersections. So one of our earliest projects was the renovation and expansion of the corporate headquarters and processing plant for United Mail, which is a bulk mail processing facility that sorted and stacked various mailing components. And when it came to designing one of their conference rooms, we thought about creating a space that could not only reinforce their brand, but also become a metaphor for what the company actually did. And so we looked at taking one material, in this case, these are sugar pine planks, and replicate, in a sense, this activity of sorting and stacking to define a pavilion structure. And so this is a basswood model of that concept. In particular, we were interested in developing a form that gave different readings, but one of them being the way that these planks were stacked, that they formed a kind of loading diagram, which shows the transfer of the wood load to the ground through vertical bands of opacity. So in other words, the structural logic formed or defined the decorative pattern. One key challenge of this project was that during its construction, the facility could not be shut down. Mail had to continue to be processed. And so this was built during evening hours by only one person, using a series of jigs to slowly stack and attach the planks. And this is an important aspect of how we think about our projects, which is that even though it may look complex, it can actually be constructed quite easily and economically. So this is the resulting conference space. And again, the vertical bands of opacity creating a structural load diagram pattern. Just as United Mail was finishing up, we began work on the Mason Lane Farm operations facility. And I'm going to focus really on only one of the barn structures by which this project is probably best known. The program is pretty simple. It's a covered structure to store large-scale farm equipment and also to store and dry square-baled hay. And of course, in our region, tobacco drying barns are a very familiar sight. And we looked at these kinds of precedents as our starting point. We were also interested in a material parallel in terms of the hay being stored inside and its relationship to grasses and to a local bamboo called Kentucky cane, which is essentially an invasive weed. We thought about using bamboo as a primary cladding material, detailed to provide some coverage from rain, but still allowing breezes to flow through the structure so that the hay could dry. By coincidence, we were fortunate to have a bamboo grower only 35 miles from the project site. I should mention at the time this project was being undertaken, we were pursuing LEED certification. And this project in a way was sort of critiquing LEED criteria at the time and looking at proving in a sense that you could build both sustainably and economically by using primarily passive strategies. And so the bamboo cladding was harvested fresh and brought to the site. This was constructed during the wintertime. And one of the more interesting aspects of the cladding installation was the development of a lashing technique, rather than the difficult and sort of tedious process of screwing individual bamboo stalks. So here we see galvanized wire ties, which you normally use to bundle rebar. And it was wrapped around these bundles and then attached to the primary barn structure. We found out in hindsight that this was actually a sort of a modern interpretation of actually a very traditional technique of building with bamboo. Traditionally, you would have used rope or hemp to lash together these stalks. And these are images of the facade installation. It's a little bit blurry here. But there was kind of a nice sort of poetic material moment in that the bamboo facade actually turned from green to gold, just like the hay that was being dried inside. And so this is the completed project. And then a view of sort of micro detail of the twisted wire ties that were left extended to form a sort of secondary texture in the facade. Our affinity for barn structures came into play again when we were asked to design a visitor center for Wild Turkey Bourbon, who were in the process of sort of rebranding or refreshing the brand at the time. And certainly we were inspired by this incredible site. The building site sits on a promontory overlooking the Kentucky River. Of course, the whole history of bird making and the rick houses used to store the bourbon barrels, the many pitch, tar, black covered tobacco barns that you see approaching this distillery. There was actually a family of wild turkeys that live on Turkey Hill, which is the project site. And then even the black fungus that covers buildings within the Bourbon Trail area, which feeds on the bourbon distillates. And so this project was an opportunity for us to reinvent an identity, again, something that was both familiar and new. We used the iconic barn form and developed a series of cladding details to abstractly allude to things, again, like the turkey plumage, the quilt patterns, and so on, but also to relate to the scale, to the vast range of scales that we were looking at in terms of the scale of the distillery landscape and the scale, the more intimate scale of the visitor. So this is a building that reveals itself as you get closer to it. It also opens up towards views of the Kentucky River. Again, I mentioned that this is the source water for the bourbon. And the interiors are detailed to emphasize a kind of orchestrated spatial movement through the building, through a series of ramps that elongate the journey to an overlook tasting room. And this is a view of the wooden trestle element that organizes these ramps on the interior. As I mentioned earlier, the use of metaphor and precedence is a tool that we often use to bring our clients along in the development of ideas. So for the Dogwood Pavilion at the Knoxville Botanical Garden and Arboretum, we used documentation of their Arboretum trees as a starting point for a coffered wood ceiling within the building. And this is the building, which has an exterior facade of folded, expanded metal, which is also inspired by, again, the bark textures. At the time, we were exploring, sort of playing with a thin plywood product called Kerf Core, which had these really extreme bending capabilities. And we decided to use this to reinterpret the expanded metal on the exterior and bring that texture inside as a coffered wood ceiling to mitigate acoustic within the space. So this is an early 3D model of that. But what was important about this was how easy this was actually to install. And so this was shipped sort of pre-fastened to plywood sheets, shipped flat to the site, and then they were expanded or pulled apart and then sort of lapped together in configuration within the ceiling. So we were essentially creating sort of expanded metal, but out of wood. And this is the completed ceiling, which recalls sort of the dappled light of the surrounding trees. And then a view of this is inauguration day of the building. On one of our more recent projects, a new event and archival facility on the Filson Historical Society campus, which is in Louisville, we were inspired by the historical detailing found in the Beaux-Arts structure on the property and reinterpreted these elements in wood, as well as referencing river and water motifs. It speaks to the focus of the Filson organization, which is to archive and share the story of the Ohio River Valley area. So the building itself is designed as a layered structure, deliberately emphasizing the way that we sort of build today with brick cavity and veneered and layered construction. So in the main lecture hall, main event hall, profiled ceiling slats, we continued the sort of sense of layering through, again, ceiling, movable shutters, and so on. And in the main event hall, these sort of profiled slats create kind of these shimmery surfaces, including a water droplet pattern on the ceiling. And this is a reflected ceiling plan of that. Both halves of the cut slats, both the positive and the negative, were used in creating this pattern to minimize waste. For an upper level event hall, we inserted acrylic slats with unpolished edges to further exaggerate this shimmer effect. And here it's applied, again, the walls and ceilings. And the effect sort of shifts depending on the quality of natural and artificial lighting. And this is the reflected ceiling plan of that space. And then connecting the two levels, we again used wood slats to recreate the profiling of historical balustrades, but reinterpreting them in a more fluid form. And these are just some images negotiating the stair. And so I've shown examples of projects where wood is used primarily in its sort of basic modular state, but I'll highlight one of our more highly customized sort of projects, which is a viewing structure for an earthwork sculpture by Maya Lin called Kentucky Line, which you can see here. We were originally asked to design a permanent viewing tower, but we were concerned with the relationship that this would create with the sculpture itself. We thought an approach that was temporary and movable would be a more appropriate strategy, something that related more to sort of infrastructure and utilitarian elements, things that we see every day and basically never remember or really notice, but they in fact exist. And so we looked at the precedent of the orchard ladder, which was particularly relevant in this case, since the site is also working farm property, in addition to hosting sort of a world-class private collection of contemporary art and site-specific art commissions. The property is called Great Meadows, which is just outside of Louisville. And so we rigged up a full-scale prototype to see how tall this would be, and also how high the client was comfortable climbing up. So this is him on the left giving a thumbs up. A critical part of the design process was our collaboration with the fabricator, in this case, a cabinet maker, who also, alongside us, created full-scale mock-ups for use as we developed details together. Here we see samples of ladder steps with compound cuts and profiling. And we continued this collaboration throughout the entire fabrication process, including steam bending the wood, profiling the handrails specific to the client's hands or grip. We actually made a clay mold to get this profile, and then testing the steel components for weight and stability. And so this is the completed project, which has a mirror polished stainless steel leg that during different times of the day seems to disappear. This can actually fold up, again, for moving. And the image on the left, again, you can see the handrail that's profiled to the client's hand for the grip. And on the right, the termination of this, again, the fusing or the grafting together of wood and steel. And this is the hinge or the pivot point at the top. The ground anchors are actually just mobile home tie-down augers to facilitate easy moving of the structure. Again, this project is intended to be moved around seasonally to different viewing locations. And the final image showing the relationship of the structure to the earthwork. I'll end on this, which is we are currently jumping to a much larger module in wood with a new event pavilion for a historic property within Louisville called Locust Grove, which features a ceiling in glulam inspired by the bark of the many black locust trees that are on the property. We just saw this recently. This is under construction now, so this is our first view of the mock-up, which was just this week. And so again, this project is under construction. And I'll end with that. Thank you.
Okay, hi, we are co-adaptive. Let me share my screen. All right, so I'm Ruth, and this is my partner, Bobby. We're principals of co-adaptive architecture based out of Brooklyn. As a practice, we focus on evolving our existing building stock to create energy efficient, beautifully articulated, and future resilient environments. Wood is an endlessly fascinating material to us, and we're excited to talk about it through the lens of one of our current projects, which is in construction and slated to be completed in the spring of this year. Through our work on it, we have learned that wood is adaptable. Existing heavy timber buildings have been repurposed to many different functions over time. It's versatile and accessible. It can be reused to take many different forms and functions, and is easier to work with both in regard to skills and tools needed than, say, metal. It's resilient. It can withstand a degree of fire and moisture, and its relative weight and malleability make it a good choice for so many things. And it's cyclical, so when it's not used, it can be returned to the earth and become highly fertile matter for new life to grow. And sort of very importantly, it's beautiful. It comes in so many different hues and patterns, and it adds warmth to our built environment that is second to none.
Today we're going to be talking about a building that is an adaptive reuse project located in the Gowanus neighborhood of Brooklyn. This is primarily a low-lying area formed around the Gowanus Canal, which was once a vital cargo transportation hub for Brooklyn. The area is built up of a network of factory and warehouse buildings that primarily date back to the late 1800s. Our site is about 100 by 100 feet and is comprised of about a quarter of what used to be a compound of networked buildings that formed the Royal Metal Furniture Company. The building dates back to around 1900. It's a double A-frame, one-story masonry shell with heavy timber roof trusses and columns and girders. Heavy timber buildings used to be very widely found here in Brooklyn, particularly in industrial neighborhoods, but fell out of favor as a construction type and essentially disappeared completely by the 1920s. The reasons were multiple and included old growth forests being over-harvested, and consequent lumber shortages. Meanwhile, land values increased and higher density buildings were called for by the construction codes, which could only be achieved with fireproof construction. So steel and concrete essentially took over. Our building has basically had 3 lives that we know about before we met her. It was initially a metal foundry, as I said, then went into becoming a warehouse and storage area. And by the time we met her, she was a artist studio and office space, just compartmentalized into dark rooms and corridors, like you see here.
To our client's huge credit, he was able to see the potential of this building in its current state and bought it to convert it to theatrical rehearsal space and studios. He came to us with the desire to create an open, light-filled space that was classic in its clarity and simplicity, and used the metaphor of the Adidas original superstars to describe his goal for design to us. His objectives also included the desire to understand the wayfinding upon entry, which is very counter to the current state of rooms and hallways, and to be authentic to the building's character and inherent qualities. With this, Co-Adaptive set out to restore the character of this heavy timber building, exposing and honoring the beautiful wood trusses and articulating the double A-frame, whilst adapting the building to meet the new programmatic function.
To accomplish the owner's vision and our design goals, the building needed to maintain its heavy timber construction classification. And because we weren't increasing the floor area, we were actually decreasing it. We could file the project under one of the older codes for existing buildings. To celebrate the wood and the masonry character of the building's interior, we chose to insulate the building from the exterior. This allowed us to expose the existing material's warmth, texture, and history of use. We even left intact the construction spray paint annotations as part of that history. This really reduced the need for interior finishes significantly, reducing the amount of drywall and paints that a project of this scale would typically have.
The large studio especially embodies the vision of the owner. This is the primary theatrical space, which can be configured to be two smaller studios by closing large, heavy Huff-core doors in the center, or to become one large open space that is light-filled and airy. We removed the interstitial floor slab on one half of the A-frame and created a 25-foot ceiling height. The existing clerestory was restored, and all the existing masonry openings, some of which had previously been reduced in size or infilled, were reinstated to maximize natural and daylight throughout. The exposed wood trusses and timber joists are red for the entire width and length of the structure, and other than some cleaning, were left completely untouched.
On the opposite side of the building, the required layout changes necessitated more than 75% of the existing first floor be removed. So we looked at mostly new column and beam grid. Because of the existing roof trusses, they needed to remain in place. We looked at, what kind of innovative solutions we could get to put in a CLT into an existing building. So using the existing timber structure to support a gantry crane, the timber structure was slid into place from the side of the building. So here's it under construction. The process of removing the floor. You could see on the right image, we first stabilized the perimeter foundation with shoring. We then installed steel beams that pocketed into the masonry along the north-south axis, and a cross beam that slid a hoist along the east-west. It was supported back to the underside of the wood trusses above. And then a bobcat was used to remove the existing wood decking. The joists and beams and columns were then carefully removed and stored for reuse. This was the GC's first time installing mass timber. They had done several theatrical projects before, but they ended up bringing a third party in to help coordinate the effort. I should note that the glue lam and the CLT came from different manufacturers. The glue lams are from Art Massif in Quebec, and the CLT is from Nordic. It was such a small order compared to most CLT projects that they were able to bundle it into what I believe was an Army delivery project, or Army project that they were delivering. So it was able to come on that shipment, and that expedited the delivery time and the costs. For the installation, the existing floor on the west side remained, providing staging ground for the mass timber erection on the east side. Wood columns were installed on new concrete footings. Glue lam beams were attached through concealed knife blade connections and Ricon connections. As you could, you can't see in this image, the CLT panels were like puzzle pieces which fit within the irregularities of the existing masonry border. So here, to install the CLT, it was first hoisted from the delivery truck through an opening in the east masonry wall. It was then slid into place by the gantry, as pictured here. A chainsaw was actually used to scribe the CLT to the masonry perimeter. We had 13 panels in total. Again, it was a really small order. And it took about 2 to 3, the GC was able to do about 2 to 3 panels per day. So it took approximately 1 week for the installation of the CLT. Another benefit of being installed in an existing enclosed building was that the timber was protected from the elements the entire time.
So working with CLT allowed us to have large column spans and therefore an open layout that worked well with our programmatic requirements. And the systems are all exposed on the underside of the CLT. This required careful planning of all the sprinkler runs, HVAC ductwork, and electrical conduit, but resulted in a very honest and clean expression of the infrastructure within the building. Working with timber also allowed us to embed lighting. This was a detail that was pre-carved into the glue lamps off-site. And we chose to express the CLT sandwich with our railing design so that you read it as you're walking down the stairs or sitting on the bleachers. The building's existing material palette becomes a very primary part of the interior. So in addition to the elements that were retained or exposed, we carefully salvaged the existing industrial doors to be used within the existing layout. The orange door you see in this image was hung from a new track and separates the administrative offices from the main entry and circulation spaces. The existing structural lumber that was removed in creating our double height space and inserting our CLT atrium floor slab appears to be longleaf pine, dates back to at least the early 20th century. And everything that was removed was stored on site and cut down in place. Existing paint finishes were flaked off, but largely retained and encapsulated in a matte clear coat, and were used for the guardrail of our atrium opening. The wood encapsulated a steel member that provides the structural integrity, and along with the clear glass allows the guardrail posts to remain in keeping with the language of the heavy timber in the building, and all the focus to remain on the wood. We also used the existing lumber as separation elements between the microperforated acoustic panels in the main studio. Acoustic separation and absorption was critical in this big open space, and using repurposed material here allowed us to add rhythm and texture to the large wall in the main studio. This additionally met our goals of reducing construction waste and maximizing the life cycle of the existing wood already in the building, and thereby additionally lessening the carbon footprint. Everything that was not used on our project itself was given to Sawkill, a wood flooring and paneling in Brooklyn that specializes on reintroducing locally sourced reclaimed wood.
Since this building is in a very low-lying area, like I described, and it's unfortunately prone to water infiltration, we designed for a dance subfloor system for the double height studio space that can be disassembled, protected, and reassembled in the space in case of a flood event. Wood, again, was the best choice for its weight, economy, and impact absorption for dancing.
So ending on a few slides of what the building looks like right now. This is it from the exterior, insulated and clad. A shot of the double height space as it is right now, showcasing the movable acoustic doors. A shot from the entry looking toward the administrative space. And a view from below the CLT slab looking towards the bleacher stairs. This space is to be used as informal gathering space where artists using the different studio spaces can mingle between rehearsals. And since we are sort of working on the fourth iteration of the use of this building, we have been asking ourselves what it might become in the future. And by extension, how adaptable is the mass timber that we inserted? How might that look in its fifth iteration?
Please reach out with any questions.
Okay, can you hear me?
Yep.
Great, okay, good. And does the screen look legible?
Yep, looks great.
Great, great, okay. My name is Z Smith. I'm a principal at SQ Dumas Ripple. The title of our session is Chopping Down Barriers to Wood Construction, and I'll try to talk a little bit about why we've headed in this way. So we are a 50-person architecture, interiors, and urban design firm based in New Orleans. And about 9 years ago, I guess, we started an in-house research fellowship program. And that fellowship program was because there are all these questions that we would like to go further in our practice than we can ever tear ourselves away from ongoing projects to examine. And so it's kind of a force multiplier. We invite typically recent graduates, people usually within around 3 years of graduation, to come and be embedded in our firm for either 3 months or 12 months or a mix of both. And we pick a theme each year. It's a little bit like This American Life. And then we just say, go find out as much as you can, ask questions, talk to academics. And then if you want to drop into ongoing projects, you can't do anything billable. All you can do is challenge and mess up the projects and ask them to go further and do some interesting stuff and maybe get some case studies out of the work. And so we've had a wide range of themes, but the last 2 years' themes kind of link together. So I wanted to talk about them and how they relate to wood. So last year, the theme was called Deep Impact Paths to Zero Carbon. And we were intrigued by the zero code that Architecture 2030 has been advancing. And that's showing basically how can we make every project a net zero carbon project. But that's in operational sense. The other goal that they had established was deep reductions in the carbon of construction. Obviously, the lowest carbon of construction is the building that's already there, and uncovering the beauty in the ones that are there now, as we've just seen in the previous session, is a key way forward. So what we've done is we've assembled in that year's fellowship 8 case studies. Some new construction, some renovation, looking at that and finding out what would it take to actually get to net zero carbon for each of those projects. And we try to price that out and so on. But in the course of that, we became more and more aware that, and I should say that the work product of this research each year, there's a booklet you can download, and this one's just about to go live on the EDR website. But the big takeaway was that, in fact, as we move to really low emissions operations buildings, the majority of carbon from our projects is going to be in the construction themselves. And so wood being the only raw material that's built directly by the sun is, of course, very interesting. And so the natural follow-on to last year's fellowship was to move on to looking at wood. And it's, as we've seen, there's an amazing past and an intriguing future. And the 2 themes that we've addressed with our 2 research fellows, Brennan Donnelly and Jake Albrecht, has been, we challenged Brennan to basically say, we're used to in the green building movement say, well, wood, it's good, right? And I think we're all increasingly aware of the ways in which how we get wood has a huge impact on whether it's actually a net positive or a net negative for the environment to use it as a building material. But then also we said is, what are the barriers for people who are just getting back into using wood? We've seen some great work in this session about using sort of dimensional lumber in new and more subtle and more rich ways. But also as we, for projects where it makes sense, especially mass timber, people want to kind of say, well, I'm looking at my project. If I were to consider using wood in that, how would I go about it? How big would it be? What would be the member sizes and so on? So that work is getting ready for being made available. So Brennan's work is about to go live as well. There's this great graphic, this is adapted from Bruce King's New Carbon Architecture, where they point out that, a tree in its life sequesters CO2 from the air to build itself, to build structure. It builds some of that, locks some of that CO2 in the soil and so on. And depending on how it's harvested will affect how much CO2 got sequestered. So how carbon negative in a sense it is over its life. And then when we harvest, depending on how we harvest it, how we kiln dry it, how we transport it, and then how well we use it, the net carbon impact of wood can be, well, it can be less than the worst case of, say, a heavy concrete building, but it's remarkably sometimes not that much less. Depending on the quality of the forestry and what happened to the forest afterwards. And so developing a set of tools to help us track and understand that is going to be key in using wood, advancing and increasing the scope of wood construction in architecture for it to have a carbon negative role that it can have if we do it right. That's sort of illustrated here through these beautiful diagrams that Brennan assembled, showing that somewhere between 30 and 50% of the biomass of a tree is actually below the ground. And then we take the shaft and then we mill it and so on, and then slice it and dice it and put it into other wood products. So understanding the flows and how much carbon is really getting locked into the buildings when we're done is sort of a key way forward. But this diagram, and I'm sure in other sessions of the conference, perhaps a drawing like this has appeared. But this is just to illustrate the idea that There's the forest, it's just there already and it's growing and we don't touch it. And what will happen over time is it will continue to sequester carbon, but actually at a slower and slower rate over time. And so if we well manage a forest, the idea here is that if we can harvest a little bit, sort of 2 acres out of 100 each year in each stand, we can preserve the forest integrity, sweep through on a 50-year time scale, and take that carbon dioxide that's been locked in as carbon and cellulose in the trees and put it inside a beautiful building and a nice safe place where we can keep an eye on it. And as we do more and more of that, by substituting for the use of concrete and steel, we can use the act of construction and the act of sustainable forestry as an act of basically locking more and more carbon that's currently in the air inside our buildings and helping to lower the CO2 levels that have already been elevated through industrial activity. So how can we lower the barrier for use of this? Because early demonstration projects with mass timber buildings have often shown that there's a $10, $20, $30, $40 a square foot premium in structure. And it is the structure that's the majority of the carbon impact of new construction. So we've been interested in what we call inside EDR gateway drugs to the use of mass timber. Here's an example of a project by another firm, Delineate Studios in Austin, that's just opened, where they've said, what if we keep the steel frame we were going to use and just substitute a CLT slab for a composite steel deck and concrete slab. And we're seeing more of that. In fact, we're seeing in our own work that in some markets is becoming a cost neutral trade-off. Our own, we're working on a project right now with a developer in New Orleans where that appears to be true. The cost difference is once we've taken full credit for the savings on other materials, getting very, very small. And depending on the market, it can be actually cheaper than doing the conventional approach and with added beauty. So why not? But this notion of this hybrid between wood and steel, rather than being, we're going to make everything out of wood, is again something increasingly seems to have some power. So this is a mass timber 17-story affordable housing project that's under final design review now up in Vancouver, British Columbia, designed by ZGF. It's fully encapsulated wood, so you'll never see it lamentably, but it is working with the forests in BC, and it's constructed again of wood slabs with, in this case, 6x6 steel posts on a kind of 12x12 or 12x8 grid with little kind of collars around them. And this approach is again helping reduce the cost difference between this and what is for Vancouver conventional construction for high-rise residential, which is to say concrete. So we've been applying that ourselves, and we actually have a couple of projects we've been doing deeper dives on. And this is looking at the carbon impact and not counting any of that carbon getting locked into the wood, but just the fact that wood takes less energy to harvest and so on than preparing concrete or steel. At a range of everything from an all concrete building to an all wood building. And what you'll see is that the kind of biggest jump in getting most of the way there is to do this again, this substitution of a CLT slab and then maybe even just a light gauge steel or cold form steel wall supporting system. So for mid-rise construction in the range of 7 to 12 floors, we're finding this is really approaching cost competitiveness. And we're working right now on an 11-story affordable housing project in Vancouver where we're advancing this approach. So let me get this to advance to the next page. There we go. So to make this tool, make this a little easier for folks to explore, we've developed a set of tools. We've developed a tool called Timber Tool. This is Jake Albrecht's work, and you can go use this today. And what it lets you try is, what if the frame is steel? What if the frame is wood? What if the columns are wood and the frame is steel, and so on? And then what if I use different CLT thicknesses? And then you can manipulate it and look at it. It will develop the optimal geometry, but then you can explore what the different geometries are. So this is what the tool comes out at for that 17-story high rise, for that 10 stories or more high rise, and so on. So you can start to see member sizes and start to get a feel for it. Let's see if I can get to the next page here. Yes. So with that, I'm going to back up and hand it over to my colleague, Mike Johnson.
Great. Hello, can everybody hear me well?
It seems to be okay, good. Go ahead, Mike, and just say next slide when you're ready.
Okay. Yeah, so I'm Mike Johnson, as he said. I'll be quickly presenting the Thaden School, which we designed, and it finished construction about 2 years ago. Next slide. This was a great collaboration between us, Eski Dumas Ripple, Marlon Blackwell Architects, and Andrew Kogon Landscape Architecture, and the Thaden School, of course. And we all had our own components to this project, but we worked really collaboratively to try to design a cohesive campus. So it's in Bentonville, Arkansas. You can see the site, 26-acre site, which is number 3, just south of the town center. Next.
Coming.
And so you'll see the site plan on the next slide, which I guess it went too far.
I'm trying to keep up with a very slow advance right now. Some internet challenge.
The campus is the layout's based on vernacular architecture nearby, and these farm courts that you can see on the right, along with the long chicken coops, the big long chicken coops, for kind of inspiration for how we laid out the buildings and the forms of the buildings. And the Thaden School has an interesting, unique kind of pedagogy with 3 main components, and that's the meals, wheels, and reels. And meals is basically a teaching kitchen and some gardens, so they learn how to grow food and how to cook the food. Wheels is kind of maker spaces and bike shop, and reels is photography and camera studios. So we did the meals part, which is the home building, which you see kind of at the bottom of the site. Next. You'll see in the aerial view the big red building to the top, which is the barn, which is a gym. As you go across the campus towards Main Street, kind of towards the camera in this, it kind of transforms from wood vernacular architecture to this kind of more contemporary metal wing-like buildings, which is a nod to Louis Thaden, which is the aviation pioneer that the school was named after. But you can see the white building in the center is the home building, which we designed. Next. Marlon Blackwell designed the 2 green buildings. So yeah, this is the home building. It's like 30,000 square feet, $220 a square foot, which is pretty good. And the campus UI is 22, which I think is 70% less than baseline. Next. Similar to what Jonathan Tate was saying, this is a completely stick-built building out of typical 2x6 and prefabricated trusses. And even though this is a very, we tried to make a very simple form with flat roof surfaces, the wood trusses actually get pretty complicated and complex and unique in shapes inside, but that wasn't really a problem. Next, yeah. So we drew a lot of inspiration from vernacular architecture, as I said before, in these wood barns and kind of the interesting dappled light that you get through the wood walls, like a screen. And also the dimensional lumber, exposed structure like Thorn Crown Chapel, which is also nearby. And this image kind of shows that the screen in the front, the exposed wood, you can see through the curtain wall in the dining hall right there, that big space. You can see the exposed prefabricated trusses at the top that you can see through that wood screen ceiling. As I said before, it's all dimensional lumber, except we did use a little bit of glulam, as you can see in that image. It was 5 glulam columns, and we tried to use the architecture as a kind of lesson for the students by exposing the structure, using a lot of wood, and kind of just showing like this is a wood building. And even the columns are designed at the minimum size. So the middle one's the widest, and the shortest one is the thinnest. So the students could even learn kind of material efficiency and structural engineering. Next. you can see here it's a massive amount of wood. So we used wood for a number of reasons, but one of the main reasons is carbon sequestration and kind of, reducing global warming. And it was also less expensive than steel, which would have typically been used here. This is a very large building to be stick built, and it just kind of barely fits into the category of type 5 construction. But if code allows and mass timber is cost prohibitive, this can be a great alternative to mass timber. Next. You can see the this is kind of like the porch environments that we have, and these portals that go through all the buildings on campus that kind of frame the other pieces of architecture. On the right of the picture on the right, we're seeing some more exposed wood finishes that we have on the exterior and interior. The rest of the facade, as you see on the left, is fiber cement board, which also has cellulose fibers in it, and we use cellulose insulation. So there's a lot of carbon being sequestered in this building. Next. This is the main space, the dining hall. It's an incredible span, which is something that I didn't even know that prefabricated typical trusses could accomplish. But again, you can see here the poplar slat ceiling, referencing the wood again, and the views to nature. So you have some biophilic elements, and making a healthy environment for the students. Next. This is a building section kind of showing that 75-foot span truss, which is actually 2 trusses that are L-shaped that meet in the center at a large girder truss. So they're kind of coming up from the ground on the side and coming across and somewhat cantilevering and meeting at the center. Next. You can see it better in this next image, but they come down on the sides and sit on those concrete pedestals. And the only reason we actually use those concrete pedestals is because these prefabricated trusses, obviously they're shop fabricated, they need to fit on a truck. And the smallest item you can put it on a truck is 14 feet wide. So that is the, I guess, the biggest truss you could make. So if we brought it all the way down to the ground, it would have been too wide. And that's why they're up on those concrete pedestals. Next. So yeah, this was the home building. I don't have much more to say. There's one thing. I mean, this building, like most buildings built today, it's built very well. So hopefully it'll last over 100 years. And obviously it's all mechanically fastened, so it's somewhat designed for disassembly. And so I'm hoping in the future we're better at disassembling buildings and reusing them, kind of like we talked about on the last project. And so, yeah, not only we can sequester this carbon for over 100 years maybe, but maybe even longer than that if we reuse the wood. So yeah, in this project, we tried to achieve great spaces and great community with simple techniques, putting the use and the user first, saving money and carbon, and creating a healthy building.
Thanks, Mike. And with that, we're done with our session. And if you'd like to wrap us back, I'll stop the share.
All right, great. We actually have like 10 more minutes. If Kevin, you wanted to show that second part of your presentation. You were on here. Maybe we lost you again.
Sure. Maybe I'll just do kind of an abbreviated version. And it kind of reinforces some of the points that Z was making, that in fact cross-laminated timber and those kind of mass timber as hybrid structures are starting to become kind of cost neutral and kind of cost comparative to to other systems. So this is a project we won in a competition. There was a huge amount of kind of, sort of an urgency to maintain the sort of integrity of the competition proposal. And it's a competition that we worked on with Projective in Mexico City. As we worked on it, it became clear that it was a far more ambitious program in the competition than they could afford to build. As you know, we started schematic design, COVID started. This is in Houston. The bottom fell out of the oil market, and really it's been kind of one crisis after another since then. But the competition was a 3-story building. As we moved our way through it, kind of challenged some of the basic competition programming. And these were kind of interior views. And as we looked at it more closely, we worked on this with TransSolar. We are expecting to use a concrete frame building, concrete columns and slabs and shear walls, primarily for the thermal mass in Houston to kind of stabilize the overall temperature of the building. And concrete proved to be very expensive. And as we continued work on the project, really started looking at ways of integrating cross-laminated timber as just kind of the horizontal framing system. Our experience in this, and this, you know, I think is now kind of a mature technology and kind of a mature sort of, you know, subcontractor pool. The construction managers went through a selection process, selected Nordique from Quebec as the fabricator. They'll provide both the steel and the CLT for the project. And as we started to, you know, kind of revise the design, you know, the CLT is actually quite flexible. And it really is the kind of steel detailing that was a much more kind of considerable kind of architectural challenge as we move forward. And I think, you know, the project really benefited in some ways from the kind of transition to this material. It gave us sort of an opportunity to kind of really simplify interior finishes and unify the kind of interior and the kind of framing system as we move forward. And I think that's, you know, in some ways that's been our experience with cross-laminated timber, is that it's, you know, it's really turned into a system that that has gone from being sort of an experimental system to one with a kind of mature market presence. And within that, you know, it really has turned into kind of a matter of kind of optimizing the sort of potential of that system. I think one of the real challenges in this project and a lot of CLT projects is to optimize overall span and kind of material thickness. And I think that's the kind of current status of this project. So I think, you know, to our surprise, you know, the kind of mass timber as a solution turned out to be, you know, kind of beyond cost competitive. It kind of solved a series of kind of objectives, you know, within the project. So I think, Shauna, we can leave it there and start with the.
Yeah, great. Thank you. I want to thank all of you again for being here today, and just give a reminder to any of the attendees that the chat's disabled, but the Q&A is working. So if you want to load any questions in there. But I really appreciated all of the different lenses that everyone presented today. So yes, we, you know, set this panel up and we asked you to present and think through a wood lens. But more importantly, what each of you talked about is the integration of wood into and within, you know, larger systems and other material languages. So exactly like what you just ended on there, Kevin. Also, for instance, Jonathan's example of a system or framework deployed to promote nefarious design, which I love that description. And in a past life, having worked on several of those projects, I think you couldn't be more accurate. But, you know, what you did was challenge the wood and exploited it to find a new language. And I think that's really what this practice panel is asking, the question. So what is the potential of designing and making with wood through the lens of the material, through the lens of wood, but not through the lens of the wood product? So I know each of you touched on that, but I think as we see products, evolving right now, maybe mass timber, how do we engage and envision the material and not be product dependent? To any and all of you, maybe Jonathan, you want to start? I'll put you on the spot.
Damn it! I knew you were going to put me on the spot. Sorry. I think Kevin would be better prepped to answer this question. How about I just hot potato it? I mean, in all seriousness, it's definitely something we think about. And you're right. It's removing the notion of the kind of obsession over a product or a thing, which honestly CLT sort of feels that way these days to me, anyways. Maybe it might be that we just not had the opportunity to work with it or engage with it in a real material way. But I mean, all that's to say is I agree with the position, and I think that's the challenge in our practices as we move through projects to try to look beyond that and incorporate things more holistically, but also see the impact or ramifications, both in a positive and negative way, of what our work is doing to the world. So.
So I'm sorry, Jonathan, so you handed me that question, and what part of it did you want me to answer? I mean, I think from our standpoint, and maybe this is, not an unreasonable sort of, assessment of everybody on the panel. We're generalists. And I think in particular within our studio, we have kind of an if-then sort of like design process. If these are the circumstances, then this is the kind of material palette we should be pursuing. And so I think we're kind of neutral with respect to kind of specific technologies, and really try to find the technology to match the the configuration of the problem and the characterization of the problem as we've defined it and as it's become clear to us. So I think in that respect, the kind of CLT use in this Houston endowment was a little bit of a surprise. We kind of felt like it came about in part because of some sort of foot dragging on the part of the kind of construction team. They thought a concrete building would be too complicated. To be honest, there were kind of complicated soil conditions there. It's Houston. There were like buried cars on the site, or just kind of crazy stuff that you'd find only in Houston. But I think as we started to work to optimize it, really the kind of circumstances and the way the problem is characterized, just within our office and within the design team, ended up really informing the sort of the nature of implementing this CLT as a strategy.
Yeah, I think the other thing that I find interesting as we sort of compare pieces of your guys' discussion is, if I can generalize that the architecture that Jonathan, Roberto, Mike, and Z presented today maybe had a rural setting versus an urban. And I think it may be more familiar to find, the wood and those formal agendas that were shared through wood in those settings. But, Ruth and Bobby, your presentation even stated how, through time, code sort of eliminated wood in our cities, and now it's reemerging, right? And yes, it's reemerging, through a mass timber way when we think about building up and building big for fire ratings. But how do we sort of bring back this wood language or identity into the urban environment?
I think I'm not sure about the how, but I think I can answer the why much more. I think the reasons why it's important are are obvious and multiple, and also the opportunities that have arisen with recent code changes allowing for the density. So to build higher with wood again, which is something that sort of went away in the early 1920s. The codes didn't allow to go any higher than, I think, 5 stories or thereabouts. And so based on, land values and the need for density, it sort of was eliminated because it couldn't keep up with the fire code requirements. But the reason it's coming back now is because that opportunity is opening back up. Both the codes are accepting some of these new products, and then these new products are, and I agree completely with the presentation that talked about how we harvest this wood. We do have to be careful about where it comes from and how it's harvested in order to make sure that we're not depleting it again. But in essence, it's a far better way of building than with steel or concrete. So I'm excited about the possibilities of densifying our cities with wood again.
I just wanted to maybe add to that we didn't show any slides on it, but we use CLT in the project for a lot of different things too. We made tables out of it. We made bathroom countertops. A lot of furniture pieces were integrated. Flexible furniture pieces were integrated into the project with it. So I think you can kind of not misuse, but reappropriate CLT in different ways that the manufacturer wasn't intending. So I think there's those opportunities as well.
Does anybody else want to build on that? I mean, I think you, Bobby, were just starting to sort of reference that idea of, the wood mentality, that it doesn't have to be, either or. It can be a both and, where it's the primary structural system, but it can also be what you're sitting on. It can be, the handle that you grab when you open the door. It's incredibly malleable and efficient as a material in that manner. So I think those are good points. Anyone wants to add on, or I can move on?
Well, no, I think that is a good point. I think, I think collectively, we have to kind of look beyond whether or not cross-laminated timber is like the new foam core. It's really not, it kind of has to be beyond just kind of this, simple planar sort of material. I think wood, as architects, we really don't have very many ways, of the last few millennia of modifying materials. We can cast it, form it, carve it, maybe extrude it and laminate it. But, the techniques themselves are pretty limited. There's maybe a half dozen. Wood somehow manages to kind of cover that spectrum. And at the same time, it's kind of readily modified, at the kind of level of an individual person. So I think that's, I think as we look for kind of the logic of persistence, I think we have to look to the kind of technique of making. And I think that's, that is kind of maybe that is kind of a connecting element between all these different, presentations, whether it's kind of like, fitting CLT into a brick building in Brooklyn, kind of similar to some of the work that Alan Organsky was showing yesterday, kind of sitting, almost like sitting neutral things on top of masonry bases. I mean, that's something that's been, that's kind of been unchanged for a couple hundred years. But I think it's a matter of kind of the integration of this kind of series of systems into kind of ways of thinking about construction that's what kind of emerges as the kind of significant contribution.
I agree completely. And I think, Roberto, your presentation really talked about, to borrow, Kevin's phrase, the techniques of making, and you shared many of the, hands-on or mock-ups that you've done in your office. So, I don't know, just because mass timber or CLT or certain products are sort of more readily available, do you think it'll influence, the way that you make and design, or how do you see maybe your engagement with wood continuing to evolve?
Yeah, it's been really interesting because we have this tendency to use off-the-shelf materials and the modules that they'd already come in. But the reality is these are actually multi-processed elements to begin with. And so 2x4 lumber, I mean, all of this stuff is heavily processed. And I thought it was interesting, the presentation earlier this morning from Zach, and using the actual split branches of wood and really working with the kind of irregularities of wood was just really compelling to me, because I think most of the discussions over the last 2 days have really been about wood in its sort of processed form. And I thought it was a really interesting attitude that Zach brought up, which the reason I'm bringing this up is that, again, it really does speak to literally sense of place and where that wood came from. And so for us, for me, I think, the use of CLT, again, I'll say it's fairly new, but I'm curious to see where we can take that in terms of, just sort of envisioning any of these projects as not being, that they could be built anywhere, that they actually can sort of be interchangeable in terms of context. And so I'm curious about how CLT and mass timber can be further customized, I'll say, with respect to a sense of place and being of its place. I think the earlier discussions from yesterday too, in terms of the sourcing of the wood and where you can get, CLT panels, because the cost to transport them and all of that begins to diminish the returns. And so in a sense, that speaks to a sense of place in terms of the sourcing of these materials. But I would be curious to see, explore where we can take these sort of processed wood goods further.
Right, I think you're bringing up an excellent point. And, in one of the earlier conversations, Lucas Epp from Structure Craft shared an amazing sort of free-form project, highly intellectual, but, it was designed, and if I understand, the wood came from, either Europe or Canada and then shipped to China. And, Chris and I were having a quick conversation about, at what point do you bring the tool to the place and to the wood, right? Like, if it's a robot, if it's a CNC, can't we ship that over there, set it up on site, fabricate some of those pieces, in order, and really rethink how we make. So maybe looking at some of the other material industry methodologies in that way, where concrete, yes, obviously we can precast and preform it, but also often the mixers are just brought on site and it just happens there. So how can we maybe find a hybrid of this process that engages wood for its ecological and construction ecology values, but also still deploys those highly sophisticated prefabrication design techniques?
I think you're reminded of the Louis Kahn, the dorm project. Was it Penn? Where was it? Where it was prefabrication, but it was prefabrication that was done on site. So they built the forms on the site and then lofted it up into position and so on. But I think that the locality, I think that some of the work that Roberto was showing was a really deep connection to the local possibilities of materials that was inspiring. To me, it's almost been a little disappointing to find out that, like, when they were doing that mass timber dorm in Arkansas, ostensibly funded by the legislature because they were going to promote the Arkansas timber industry, and in fact, the low bidder was from Austria. And that really reflects the embarrassing factor, it's just the way the world is now, that it takes remarkably little energy and carbon to move things around the whole planet if you're moving it by a boat. I think the metrics are something like, it's the same carbon to move it 20 miles in a truck, 200 miles in a train, and a couple thousand miles in a boat. And I'm just making up those numbers, but the fact is that I think that the things that we've been discussing here is that the hyperlocality comes from more of an awareness of even the patterns. Yes, it can be local wood. Yes, it can be a local bamboo. But I think the other possibility is to just be more aware of what the regional patterns are of how people have been using these different materials and try to pick up on that just as well.
Yeah, I'll add on to that. I feel like it might not be as important to focus on the transportation part of it, but more transparency in forestry and knowing where the wood comes from, like forest to table, I like to call it, if we can have that in the future, more so to look at the forestry practices that are happening where your wood is coming from, even if it can be far away, and that's fine. But yeah, to me, we were talking about the why and the how earlier. It's very straightforward to me why. I mean, it really does seem like wood is a way better material to use for carbon and embodied carbon than concrete and steel. So, you know, most of the projects we do are mostly steel and concrete. So just trying to push wood at all, to use wood at all, has been interesting. And then of course, you know, as I was saying earlier, the building gets too big, you need to use mass timber. So that's pretty straightforward too. And so as we learn how to use the CLT, you know, the how, that's really exciting to me because it is kind of relatively new. I feel like there's so much opportunity to hone that craft and understand different ways that we can use mass timber.
Yeah, and in addition to honing a craft, I wonder, you know, as architects, as the specifier, as these materials, you know, we have clients who have programs and desires we have to, you know, answer, but we also know that we lead so much of that. You know, how do we have a larger role? How do we make some of these conversations happen? You know, and in the same time, you know, the tree to table, what, you know, how do we demand that for other materials, right? So, you know, we're not just saying wood everything, but, you know, how do we say this sort of call to order for wood, and does it go to the entire material palette? And maybe referencing Andrew Freer's layer cake cluster F from his earlier presentation, you know, in terms of really thinning the building envelope and the material palette that we're building with.
I think there is an interesting thing that's happened because of the nature of how information systems are growing, which, you know, let me do the one-liner. The one-liner is today when I get a dozen eggs from the store, I open it up and there's a little thing that I can scan with my phone, and I can actually see the chickens from that small producer. And what they've done is they've set this mechanism up so that even though it's not next door, that these eggs are coming from a couple hundred miles away, I have this kind of connection, and, you know, there's a matter of trust. Are they, you know, is this for real? But let's assume for now it is. There's this really interesting potential, as opposed to, nobody wants to look back and see the open pit mine for the taconite where the steel is coming from. But there is this possibility that we could make buildings with wood that help build a connection between people when they look around them and say, and here's the forest in its place where that wood is, where it came from, and you can see it's a healthy forest and you have a connection to it, and so on. And I think there are some really interesting efforts going forward on building this connection. Even if it's a highly processed material, there is this chain of connection back to a place that's growing it, and it gives you a sense of being part of a time scale that normally we completely ignore.
Yeah, and I'm sure Peter McKeith will be talking about this. You know, I think this sort of Northwest Arkansas Timber Initiative, you know, is a big part of, you know, the kind of reconsideration of this as an overall kind of systemic approach. You know, I think only like 60 years ago or so, like some 30% or so of the blue collar jobs in Arkansas were in timber. And as that industry changed to basically produce paper pulp that just kind of got thrown away, you know, all those jobs went with it. And so I think the kind of initiative of kind of reconnecting the kind of logic of labor with a specific geography is a big part of it. But I'd also like to kind of, I don't know, return to something Jonathan kind of started out with, which is like, you know, the 2x4 is kind of almost all right. And there's a reason for that. And this friend, you know, Tom Burrish, who was the chair at Michigan and then Berkeley for a long time, you know, is kind of a curmudgeon and would say, well, this is really interesting, but when can I buy it at Home Depot? And I think, wood, especially mass wood and mass timber as kind of a normative system, I think it's really only at that point that we'll be able to start evaluating what its implications are for a more substantial impact on the way we build and the kind of energy and body carbon and things like that that are implicit in construction.
And if I can add to that too, I think that's also where whenever it becomes available or customizable, and I appreciate your use of the word carpentry, which I've not heard it in a while, although I'm around it all the time. It's just nice to hear that term. But when mass timber begins to create a language that's about mass timber and not about the replication of other building elements, whether it's steel or whether it's concrete. And that's what I'm curious to see is how it evolves into a point where it's recognizable for what it is and not for what it's attempting to replace, right?
Yeah, I think your guys' comments are exactly right. And I want to read, I know that Z answered it, but I want to read one comment from Tom Chung, who was one of the architects for the Adohi Hall. So I just, following up on your comment, Z, he wrote this. For Adohi Hall at Arkansas, since there wasn't a local CLT plant in the region at that point, the choices were trucking it from either West or East Coast or by ship from Europe. And while cost was the primary factor, it was interesting to see that transportation by ship had a lower carbon footprint than by land vehicles. Since then, the Dothan, Alabama CLT plant, which is Smart Lam, has opened, and Walmart with Structure Lam will build a plant in Arkansas. And he mentions, yes, our next speaker, our keynote, sort of closing out the event for us is Dean Peter McKeith, who has been referenced a few times. So yeah, that is also one of the things, the topics that we discussed yesterday when we had the manufacturers. We had Structure Lam, we had Structure Craft, Smart Lam, and Ferez Lumber, on a panel talking about what is the infrastructure and the logistics currently in working with these mass timber products, and that there are North American, representatives, and we hope to grow that network, in the U.S. But also, how do we grow that network? What is the correct path? One of them referenced that they're manufacturers, and typically they're not the interface with us as designers, right? They manufacture and somebody else fabricates, and the fabricator would interface with the designers and the engineers. So it's a little bit clumsy right now, that process. We could probably all speak to, if we've worked with mass timber products right now, the CLT, it's a little clumsy, and it's not as nimble. So I think, that's another one of the conversations is how does the network grow and become more nimble, and how does that allow us to have more access to it as a method of making, and then therefore challenge how we make with it. I guess I was pontificating and not asking a question, but if any of you guys want to add some final thoughts, we're sort of wrapping down. So I open it up to you guys for a final thought.
I just want to say that kind of reminds me of Katera, which whether Katera is bad or good, I'm not sure, but they're kind of fabricating. They also have architects, and it seems to be streamlining and completely changing that process, that typical process. So maybe learning from Katera and maybe doing something similar to that or something different, but there are ways to kind of break the normal process that we have currently, and maybe rethink it. And mass timber and CLT might be a kind of way to do that, since it's somewhat new still.
Yeah, I mean, I think it is new. It's also kind of around enough to be, approaching what's normative. We're working on a small project in Bentonville, Arkansas. It's an affordable housing project. It's over budget. And at one point, the contractor said, well, maybe we should be using mass timber. And so it's like super counterintuitive in terms of like, oh, maybe we should use this thing that's always been cost prohibitive in the past. But because of the sort of market presence of the kind of different mass timber initiatives there, it seemed like a possibility. And then the structural engineer said, well, at Arkansas, at the dorm, they get, 2 plumbing leaks a day. And, before you guys get us, started on this mass timber, when there's a leak, are you also gonna have a structural problem now? Because the sort of idea that, that a kind of long-term leak could end up really undermining the sort of, the structural integrity of the floor system is not something we've had to deal with as architects. So I think in some ways the kind of, we have to use our own sort of empirical kind of intuition as builders, and the kind of the level at which we can bring being really street smart to the kind of subsequent, to kind of, forthcoming installations and uses of CLT, I think will make a huge difference. I think that's what's going to be pushing it along, and really kind of using the kind of, our builders sort of notions of how things should be done, and not just kind of adopting this new technology as if it's all going to be kind of neutral and good, I think is a really important part of the kind of success of it in the future.
I think one of the things that, piggybacking on that is how we adapt buildings that if they are a CLT project, let's say, and you cut a big hole in the floor to put a stairwell. How do you get that out? How do you reframe that after? I mean, these are kinds of things of how do we adapt these CLT buildings? And we kind of touched on it in our presentation, but it's an open question on how adaptable this technology is. And I think that's really where architects are going to come in to think of new ways to start to kind of meld these things together, to hybridize them, to reinsert craft in recreating these after they're 50 years old or 100 years old. How we deal with that.
There was that wonderful section in Stuart Brand's book, How Buildings Learned, where it's a pay-in to the old Building 20, W20 on the MIT campus that was built as a temporary building during World War II using timber, heavy timber, and then wood slat floors. And it was thought to be that they take it down right after the war, but in fact, when I was at MIT in the 70s, everyone was still there and loving it. And eventually it got replaced with a Gehry building of mixed reviews. But what he says in that passage is everyone loved the building because, like, if you're working on an experiment and you needed an extra 4 feet for your apparatus, you just went upstairs, knocked on the door and said, do you mind if I carve a hole in the floor? And then the equipment went on up through to the next floor because it was, I think in one of the earliest talks, the idea that wood is this material that we all go to Home Depot and get a tool to go mess with, and we don't think of doing that in steel and concrete buildings. So the inherent adaptability of wood, whether it's CLT or not, is, I think, a great virtue, and it's a virtue that we should wear on our sleeves.
I just wanted to add that when Kevin began talking at the beginning, he was showing us those examples of the custom cutting for those rafters, and I'm reminded, given all the, I think, presentations on CLT, for example, and the emphasis on precision and fit, but the reality is, there is this sort of third or fourth layer of manipulation, which is the people that are actually installing the stuff. And that CLT, just like regular lumber, you can saw into it and hack into it, and that's where I think the fact that it's the perception of it being so perfect, maybe to look at it more in terms of it's a starting point, right, that you can then manipulate. And so I was just thinking about how, again, beginning with Kevin's talk, how all of that is sort of manipulated and filtered through sort of so many layers of coordination, going right down to the people that are actually installing this stuff. And I also often think about things like, local skill sets and familiarity with emerging technologies or products. And there is this sort of other, oftentimes hidden layer of filter in using and installing these products.
And from what Kevin is saying, it's clear that Arkansas has great skill in working with wood, but what they need is better plumbers.
I think that's a default of the students being a dorm, not them.
Yeah.
Don't
And
want to
I
get
think
in
it's,
trouble with Dean McKees, who's up next.
yeah, and I think I'm sure he'll want to address that. And I mean, it's one of these things where, where individual sort of components, like plumbers feel like entire buildings exist for them to hang fixtures onto, and I think you have to take any kind of comment like that with a grain of salt. But at the same time, you know, when we do affordable housing projects, we always depress the floor and waterproof the entire bathroom. And so there's also a solution for it. My only point is, like, we have to be as street smart about new technology like CLT as we are about any kind of building technology, and that's what's really going to push this forward. And that's my only point.
Right. And on that note, I want to take this moment to thank you guys all again, and to reiterate, that's why we've had, this space yesterday and today with these panels and these conversations, that it's really about the education. And again, if you guys were able to, attend some of the talks yesterday or today, we'll hope to share them in the future online. I know not everybody's been asking if they'll be, available, so we are recording them, but it's really about creating this educational platform for students, but also, who are our future profession, but also those practitioners, designers, engineers, builders right now, right? So we started in ecology and forestry, as I mentioned. We went through sort of the emerging industry and manufacturing, and today, all of you sharing a very sensitive approach to understanding wood and to questioning wood, and just like in the panel right before you, there were three, different sort of makers that exist in Academy, all innovating with wood, but the result was quite different because the tools and the methods were different. So again, we appreciate you sharing, your methodology and helping us build this education platform.
Thanks, Sean. And Chris.
Thank you, guys.
Thank you.
Chris been this whole time.
Thank you for doing this. Big fun.
Yeah, thank you all.
Everybody in the keynote, starting in 50 or 10 minutes now. The link is in the chat. So I'm going to end the session now. So grab that link and we'll see you guys over there. Thank you.
Okay, great.
Thanks so much.
Thank you.